first thing we want to do is we want to review a little bit about inverse trigonometric functions. We've been talking about inverse functions in some of our other recordings. First, let's remember our trigonometric functions: sine of x, cosine of x, tangent x, cotangent of x, secant of x, and cosecant of x. None of these functions are one-to-one in their general form, because each one of these graphs would fail the horizontal line test. In order to make these trigonometric functions one-to-one, we will have to restrict the domain. What that means is, if I look at sine x just between negative pi over 2 and pi over 2, the first graph up here in the upper left-hand corner, then I have a one-to-one function, and I can find its inverse. If I just look at cosine only between 0 and pi, I will have a one-to-one function. Now, I cannot look at cosine between negative pi over 2 and pi over 2 because its graph would not be the graph of a one-to-one function. So we have to put a restriction on each one of these functions in order to be able to find its inverse. This shows the graphs of those 6 basic inverse trigonometric functions. Now, remember, the inverse is what we get when we switch the x and the y. So when we look at a specific x value, and let's say we take the sine of pi over 4, which is the square root of 2 over 2, then the inverse sine of the square root of 2 over 2 is pi over 4. So we are switching our x and our y values. Notice that we're only looking in a range, and that's important because if you remember about our trigonometric functions, there are an infinite number of places, or an infinite number of angles that will have a sine of the square root of 2 over 2, because not only does pi over 4 have a sine of square root of 2 over 2, also 3 pi over 4 has a sine of square root of 2 over 2. And any angle that's coterminal, so if you add or subtract multiples of 2 pi to each one of those angles, any of those coterminal angles will also have that same sine value. So we have to put restrictions in order to make this inverse sine a function. And same for each one of these. Now here's how inverse sine is written. It is written with a -1, just like we had when we were dealing with functions and their inverses. Remember, we used this notation for inverse of function f. That's why we use this notation. An inverse sine is a number between negative pi over 2 and pi over 2 for which sine of y is x. And then y equals inverse cosine of x is a number between 0 and pi for which cosine of y equals x. Okay, here are pictures again of our sine function and its inverse. And here's a picture of our cosine function restricted here and its inverse. In both cases, the graphs are reflections about the line y equals x, just like we saw when we were talking about inverse functions in previous sections. Now, if I'm going to find the inverse sine of the square root of 3 over 2, that means I'm going to be looking between negative pi over 2 and pi over 2 for an angle that has a sine of square root of 3 over 2. And the answer would be pi over 3. That is the angle in between negative pi over 2 and pi over 2 that has this as its sine. So when we're finding inverse sine, that's what we're doing. Remember, the inverse sine can also be written as arc sine. You'll see this notation from time to time, and it means exactly the same thing. So instead of inverse sine, sometimes you see arc sine, and instead of inverse cosine, sometimes you see arc cosine. Similarly, arc tangent, arc cotangent, arc secant, and arc cosecant. So it's just different notations. For inverse cosine, we are looking only between 0 and pi this time. And if I find inverse cosine of -1/2, I'm looking for the angle between 0 and pi that has a cosine of -1/2. And that will be this angle, 2 pi over 3. Here just gives us a few common angles, or common values. For example, square root of 3 over 2, the inverse sine of the square root of 3 over 2 is pi over 3. That's the angle between negative pi over 2 and pi over 2 that has square root of 3 over 2 as its sine. Inverse cosine of square root of 3 over 2 is pi over 6. That is the angle between 0 and pi that has a cosine of square root of 3 over 2. Here is the notation for inverse tangent and inverse cotangent. Inverse tangent is going to be a number between negative pi over 2 and pi over 2. Inverse cotangent, however, is between 0 and pi. If I want to find the inverse tangent of 1 over the square root of 3, I look between negative pi over 2 and pi over 2 for the angle that has that as its tangent, and it would be pi over 6. When I find the inverse tangent of negative square root of 3, I'm looking between negative pi over 2 and pi over 2 for the angle that has a tangent of negative square root of 3. Now, this is just a quick review of inverse trigonometric functions. In the next recording, we will actually be finding the derivatives